and welcome to Climate Chat. I'm your host, Dan Miller, with my co-host, Leon Simons, who's had a little trouble with his camera. We'll see how that works out over time. And today we are talking about a new report from the German Meteorological and Physical Society on reaching 3 degrees Celsius by 2050. And the way I would put that is that, there could be an alternative headline: large asteroid to hit Earth in 2050, and yet no one is covering it. So we're going to talk both about the science of this prediction, as well as the sociological implications of this, because I just got back from Climate Week in New York City, where there's tons of, literally hundreds of events going on regarding the climate. And I think this ties into that in an interesting way. But with no further ado, I want to welcome Leon here to tell us a little bit about this new report. Welcome, Leon.
Hi, Dan. Yes, let's dive into it. I'll share my screen. Yes, so this is a new report that was published last Thursday. It's by DMG and DPG, which are the Deutsche Meteorologische Gesellschaft and the Deutsche Physikalische Gesellschaft, which indeed means the German Meteorological and Physical Societies, which published this call. It's like a warning call where they present the science and an update on where we stand with regards to climate change, from the perspective, of course, of the German Meteorological Society and the Physical Society, and that's in Europe, that's quite an authority, and of course especially in Germany. And what they say is plainly, global warming is accelerating, and they call for decisive action. And what they include this graph, and I think that's this similar summarize it quite well, where they show that during the period of human civilization, when we had agriculture, the planet hasn't been as warm as it is now. It hasn't been above 1 degree Celsius warmer than it was before the Industrial Revolution started. And then at the moment, we are at about 1.5 degrees Celsius of global warming, and we could reach as high as 3 degrees Celsius in 2050, and of course then later century even higher, and that's, as they mention, at the rate we are going now. So I think that this is quite a message.
And then 5C by 2100 is also kind of mind blowing as well. But 3 to 6. But I think the important thing is it would be like getting back to the asteroid example. And people might say, well, it's there's no proof that we're going to hit 3 degrees. You can't prove that. I mean, whatever. It's
not the point.
Well, it isn't the point. And this is actually a really important point when it comes to climate change. And it also gets back to a lot of the stuff that happened at Climate Week. In science, you like to be able to prove things. If you're a professor and you're writing a research paper, you can't publish that paper. And I mean, you shouldn't publish that paper unless you're like 95% certain what you're writing is correct. You have like a 2 sigma kind of thing that you're right. Yeah. And which is fine, by the way, when it's black holes or some other kind of physical phenomenon that we can take our time in learning about. But it's not okay when it comes to climate change, because if there's a 50% chance of like hitting 3 degrees, let's just say, let's pick that as an example, by 2050, that is absolutely mind-blowing. You would never, ever in any part of your life take a risk like that. And it would be like saying you're going to put your children on an airplane and they come out and say, well, if they said it's 95% certain the plane is going to crash on the way to the destination, everyone would agree, okay, we're not going on that plane. But it's like saying the pilot comes out and says, by the way, there's a 50% chance that the plane's going to crash on the way to the destination. But don't worry, it's not a 95% chance. So go put your children on the plane because it's only a 50% chance. I mean, you wouldn't do it if it was a 1% chance. Airplanes are like the safest thing you ever do because they measure these probabilities of 1 in a million kind of thing. So, and anything above that, they just stop. They don't take off, or if it's in flight, they declare an emergency and they land. They don't take chances when everyone's on the plane. Well, we're all on this plane at a T to the end.
They don't take the risks.
They don't take the risk.
They don't accept the risk. Of course, there's always a risk when you fly an airplane, but they don't accept risks above a certain threshold. So they do everything they can, of course, to avoid the worst outcomes. And
right.
Otherwise, and they are, of course, they are held accountable if the plane does crash. And I think it's, maybe let's go a bit further into this into the
very important
subject.
Not just the science of it, but how we're all reacting to it. The fact that we're doing this show with this headline, and it's not on the cover of every newspaper in the world, just tells us something that we treat the risk from climate change very, very differently than we treat the risks of everything else that we face in our life. Let's keep going.
Yeah. So I think that's, they really clearly say that there is acceleration of global warming, which of course we had been warning about already for years. And as expected, after 2023 happened and 2024 happened, the uncertainty of this acceleration has decreased significantly, and that's also one of the reasons why I think more institutions are open to clearly stating that there is acceleration of global warming, and that, of course, results in also a higher estimate of near-term warming. And I think that's, to me, that's really the main risk, that we will have a lot of near-term warming, much more than most have anticipated. And of course, that's, as I think everyone acknowledges, every expert acknowledges, that the risk of climate change, one of the main reasons why climate change is such a risk is the rate of change. If the rate of change has doubled, maybe even tripled, as this suggests, then of course the impacts will be much higher as well. It will be much harder to adapt to these rapid changes, and that's also what the report clearly mentions. And I think this is this is about they advise to discuss withdrawal from low-lying coastal regions on the North and Baltic Seas. And I live in the North Sea, right? I live in the North Sea region, where over 30% of my country is already below sea level. And if we will have multiple meters of sea level this century and the next, of course, we will, and we are already doing that. There's already some discussion, at least among experts, about what do we do, how do we make sure that when the shit hits the fan, that we're able to migrate to higher lands. And whether that's there was a documentary maker who went to Norway, for example, as a joke, but also quite seriously, to ask if we would be welcome if our country will disappear because of sea level rise. And they responded as, of course you are welcome. You have the same culture as we have, and we have a very small population. We have many jobs, so you're most welcome. And of course, the migrants will not just come from the Netherlands. I think that's what the documentary maker also tried to make quite clear, that, and also in a way, the hypocrisy that, of course, that just saying you are welcome because you have the same culture,
Right.
of course, that's in a way.
And it's not going to be just the Netherlands, by the way. It's going to a lot of countries, and not just because of sea level rise, because of extreme heat, and therefore drought, and therefore no agriculture where you live, and therefore, Central America, and I mean, this is in Africa. This is already happening. In fact, if you look back to the Syrian conflict, as Tom Friedman wrote about this, and I think a whole book on it, that was actually exacerbated, triggered, you get different words, by a 5-year drought. Before that, farmers couldn't grow food. They went to the cities and stirred up trouble. That caused conflict, and that caused people to leave Syria. Most of them going to Africa, by the way, but a small portion went to Europe, and this drove Europe crazy. They implemented all these policies against migrants and things like that. And so, and that was like, at this point, what, 10 something years ago? I mean, it was a long time ago. And yet that little bit of migration, climate migration, caused a lot of problems. And now imagine that at 10 or even 100 times more than that. It's not going to go well.
And it was also quite strange to experience then when the Russians entered Ukraine, that the Ukrainians were welcomed, and of course there was a discussion like at least from the Dutch perspective, they were saying that they always encourage regional refugee settlements. And then, of course, then it's okay. Now we are the region in a way. Now Europe is the region. So now we had to take them in. But yeah, one thing that was saying, okay, they have the same culture as we do, so it was easier to accept them as refugees, I think. But yeah,
coded language in there.
No, it's often there is some racism there. Of course, it's not really coded. It's plainly obvious.
Right, yeah, it's probably obvious.
But because it's in a way like it's like positive racism, and then the ones saying it often don't realize what they're saying.
So, by the way, the science behind this report, is this coming out of the paper from you and Jim Hansen, Global Warming, the Pipeline? Is there new independently done research that they're using, or are they more collecting the research that's occurred?
Yeah, they're collecting the research, and they of course they cite also our paper in their report, and of course many other recent studies. And of course we have the IPCC report that comes out every 5 or 8 years. That also uses there's not a separate scientific report, but that's accumulation of the most recent science. And of course, this is in a way you could see it as a regional update of the climate science. So, yeah, again, accelerated warming is a threat to life and limb. And here we get again to the migration. Also, like increasingly extreme weather conditions are making predictable agriculture difficult, and in some cases impossible in large parts of the world. I think that's really, the main message, right? If you cannot grow food anymore, that's a big risk, and that's caused, of course, because of heat, but also because of potential AMOC slowdown, and as we discussed before. So what they say is, for hundreds of millions of people currently primarily in the global south, these developments pose a very high potential for impoverishment and famine. And there's a high risk that the limits of habitability will exceed in some region of the world. And of course, if you read that, there is a high risk that the limits of habitability will be exceeded in some regions of the world. It's like people will die. people will start dying because of climate change. That's in a way what it says, right? And it's often this language, and of course we do it as well when we write scientific papers. We had a similar statement in our paper in 2023, led by Bill Ripple et al. And others, where we also said that the risk of habitability is or the limits of habitability are coming in sight, but it means that people will start to die because of climate change, and this would significantly increase the likelihood of people would be forced to leave these regions. Of course, they could move, but then we see that already that it's they are trying to move already from Africa, from famine, for example, and from South America. But there are fences and walls being built to make sure that they cannot come across the borders, right? And that's already happening while there is plenty of food to go around. I think that's also important to realize that it might get much worse when climate change gets worse.
Mm-hmm.
So yeah, they say we need decisive action. And I recommend everyone to, I think it's in the description, Dan.
This link to this is in the description. Yeah.
The link to this is in the description. I recommend everyone to read it. I think they're going to publish it in English as well, but I translated this, and it's in German, but I checked and I speak both German and English, and it's translation is automatic translation is fine as far as I could determine.
Okay. Yeah, I put the link into the English page, but it hasn't been translated yet. So the English page is in German, but maybe in a few days it'll be updated or something.
Okay.
But yes, otherwise just do automatic translation. That should work.
Yeah.
Great.
Oh yeah. Again, I included this twice. So again, this graph, and it might seem a bit controversial to some that we could reach 3 degrees by 2050, but it's not controversial at all. That's also what if you just do the extrapolation, and this is from the ECMWF Era 5 data with Tuberg Samur plotted using their code. And you can see if you have this nonlinear extrapolation of the past 30 years to 2030, we would reach it already around 2050, right? And then, of course, we don't know. I think September will be about 1.5 again. So there's quite some uncertainty, but that doesn't mean that that it won't happen. Because, of course, if you look at the Earth's energy imbalance, as we've talked about here many times before, you see that it's above any of the scenarios, right? The observations from NASA are above the scenarios, above the climate models, whatever scenario you put in, because of the near-term warming is much higher than the global heat uptake is much higher than in the models.
Mm-hmm.
And here this a table I extrapolated further, and from this global warming has accelerated significantly preprint from Grant Foster and Stefan Ramsdorff, where I show also that if you extrapolate, of course, then linearly and that's the warming rate they determined based on when accounting for natural variability of the sun and of volcanoes and of the El Niños and La Niñas. When they account for that, they got these different from NASA, from NOAA, and all these different data sets, and they get these points where we will cross 1.5 degrees Celsius. And then because of this rate of warming, and if you extrapolate that linearly, then you will get to 3 degrees, so on average in 2060. But of course, that it could still, as the paper mentioned, it could also increase or decrease the rate of warming. So we don't know, but it's and here another one where you show these different models, and where you have from the latest IPCC report, where they show that using these different scenarios, and then in degrees Celsius, like the worst case scenario in like I think that the 5% chance within these models there's a 5% chance of reaching 3 degrees, or 3.2 or 3.4 when using these scenarios. So that's.
By the way, I think it's important to mention that you use the word scenarios, and these are scenarios. They're actually not really predictions. A prediction would say, this is what I think it's going to be. It says, this is what we believe the temperature will be if the world follows these scenarios, the SSP scenarios. But those SSP scenarios have certain assumptions about energy use, for example, how much fossil fuel burning we're going to do versus, getting rid of it, which is, by the way, in our hands. Some people, we had Bill McKibben on just a couple of weeks ago, and he felt that because solar is so cheap and it's liberating in many, many ways, that it's actually unstoppable and going to grow rapidly, even with what the Trump administration is doing in the U.S. I mean, in China, it's accelerating tremendously. So there's those kind of assumptions could be wrong. But then again, there are assumptions that. Let's get back to.
Sorry.
There we go. Let's do the welcome one. Oh, there we go. Okay. There are assumptions in here about feedbacks like permafrost melt and clathrate release, on and on and on. And about aerosols, about how fast we clean up aerosols and things like that are not necessarily reflected. Well, the reality of what will happen is not necessarily what's built into those SSP scenarios. So I do want to emphasize that these are scenarios, and these are not inevitable outcomes. We the future still is in our hands. I mean, as just one example, something we talk about on the show a lot is geoengineering, and so we could artificially cool the Earth. We are artificially cooling the Earth today on a massive scale. We're just not doing it for that purpose, but it's intentional.
Unintentionally we're doing it.
Well, it's intentional that we're burning the fossil fuels, and we do know those fossil fuels give off aerosols, which cool the Earth. So it's, I wouldn't say accidental. It was just not with that purpose in mind. And so all of these things factor into what's going to happen. But I also have to say that we're talking about 3C by 2050. But if you looked at your chart before, it also says we're going to hit 2C in the 2030s sometime, which is only 10, 15 years away, depending on what time of the decade.
Yeah.
And that is utterly catastrophic. People don't, we think of 2C as some safe number because we use it, like in the Paris Accord and everything, as the the threshold or the target temperature we're trying to stay under. And the implication is, if it is a target temperature you're trying to stay under, is that staying under it will keep you safe. And that's not true. I mean, it is safer than 3 degrees, and that's safer than 4, but it still will lead to far more drought and flood and wildfire and extreme weather than even today.
Even
go ahead.
If you look at, we're now at about 420 parts per million CO2 and over 570 parts per million CO2 equivalent, and that's higher than the mid-Pliocene warm period, that's 3 million years ago, which is almost impossible to imagine how long ago that is, right? That's before. The last ice age was 23,000 years ago. It was the maximum when sea levels were 134 meters lower than they are today. And that's 20,000 years ago. And you have to go back 3 million years to get to reach a temperature equal to what we have experienced in.
Well, we're not there yet, though. I mean, this is 2.5 to 4.
Yeah, so
I mean, we're on our way to that, but we're not up
that's
there
what I
right
mean.
yet.
So,
Yeah.
But so you would have to go back 3 million years to reach to find a temperature, a global average temperature equal to what I could experience if I live long enough, right?
Right. We're on our way, and that's
and even then you could reach that level if you live long enough. If you live, let's say, 20 years, you could reach that. You could experience a temperature that hasn't existed for 2-3 million years. That's like
right.
That's and that changed within one lifetime.
Right. And people think, I mean, people don't pay attention to this, might think, well, it could go that high, but maybe it'll go lower or something like that. No, that's not the way it works. We have an Earth energy imbalance that we can measure today, and it's very large. And that means there's more energy coming in than going out of the Earth. And whenever, like this is just physics now, this is not sociology, when there's more energy coming into something than going out, that thing is going to absorb energy and get hotter. And so it is inevitable that we will continue to go up in temperature, not only because we're continuing to burn fossil fuels, but because there is, let me make up a phrase, there's global warming in the pipeline, and the Earth energy imbalance requires that the Earth get warmer, unless we take artificial steps like geoengineering or something like that. So, and what I want to emphasize again, though, is that 2C is terrible. Okay, it's catastrophic, and in 15 years, right? And yet, we're on our way to 3. And if you recall our conversation with Kevin Anderson from, I don't know, like 6 months ago at this point, maybe longer, when I asked him about his quote that he made in 2010 about 4C being incompatible with an organized global community. And he said, well, given what we know since then about how impacts are worse than we thought and this kind of thing, I would probably update that to be 3 degrees. So we're talking about a temperature that could destabilize civil society. By the way, it doesn't mean that everyone becomes extinct. Doesn't mean all humans die. I mean, it's a lot of humans die, but it's more like you're devolving into a Mad Max scenario where people are getting by on their own because there isn't a government around to organize things and help with response and things like that. And that's going to be true in more and more places, and poor places that don't have much to start with, and then they don't have agriculture. It's very difficult to have an organized government in that situation, more like Somalia kind of situation. So anyway, that's these numbers are mind-blowing and not being discussed at all in the mainstream press right now. It's a pretty crazy situation we're in.
Mm-hmm. Yeah, and then I think we get to this in a way discussion of let me try this.
Club of Rome.
Yeah, so this is from the 1972 limits to growth report, which is mainly about the limits to exponential growth as well, where you see so I think this is one of the first times when what it is that they used a model, an Earth system model, to see what will happen if you have a system with population growth and increased resource depletion and increased pollution and dependence on food. And so what they found was that there are, as the report is called, limits to growth. So there are limits to how much you can grow pollution. There's limits to how much population can grow. There's limits to how much food you can consume, and that will lead to almost certain collapse if you have a system that keeps growing. So of course we have pollution that keeps growing. We keep emitting more and more CO2, and this is quite accurate. If you look at the CO2 level of CO2 emissions, were almost exactly as produced by the model in the real world. There was a small dip in 1991 because of a volcano that cooled the oceans, so the oceans took up a bit more CO2 than otherwise would have. But besides that, the rate of CO2 growth almost perfectly fit this line. So you have this increase in pollution and increase in CO2 accumulation in the atmosphere, and that wasn't covered well in 1972 because we didn't know that there would be so much climate impact from that CO2 at the time. There was some research on that, but it wasn't as well accepted science as it is today, of course. But now that turns out that will be, I think, the main challenge for food production and for population. And so this is with the world natural resource reserves doubled. And even if you would have them like unlimited, so if you would really have an enormous amount, it doesn't change much, right? So you can discuss whether the x-axis or the y-axis are accurate or what it means, but I think that it was, of course, from 1970 or 1972, it was already quite complex to produce such a, in a way, simple model. But there was, we didn't have the computers at that time that we have today. But yeah, the output is quite alarming. And so at that time, we were already talking about billions of deaths because of collapse. And the big question is, of course, when it happens. And I wanted to share some, I uploaded them, but I wanted to share something Dennis Meadows talked about when we interviewed him in the Netherlands when he was here. And Dennis Meadows is one of the authors of the Limits to Growth report from 1972, and also next studies. But I think, does this work?
Well, you can try.
Yeah.
Good. Go ahead.
Yeah.
Expect that we're going to avoid collapse. I'm not sure what it will look like. I mean, and so I simply don't know. I have many different scenarios, but actually we don't know. It's not knowable. I mean, some huge volcano could blow up tomorrow in Indonesia, which reduces the agricultural output of the planet by 40 or 50% for 5 years. How do we know that could happen? It has happened several times in the past. So usually speaking, something which happened in the past could happen again, generally. So that could happen, or epidemics. I mean, I don't know what it will be, but in one way or another, we are so far, globally, we are so far above the population and the consumption levels which can be supported by this planet that I know in one way or another it's going to come back down. So I don't hope to avoid that. I hope that it can occur in a civil way, and I mean civil in a special way, peaceful. Peace doesn't mean that everybody's happy, but it means that conflict isn't solved through violence, through force, but rather in other ways. And so that's what I hope for. That we can, I mean, the planet can support something like 1 billion people, maybe 2 billion, depending on how much liberty and how much material consumption you want to have. If you want more liberty and more consumption, you have to have fewer people. And conversely, you can have more people. I mean, we could even have 8 or 9 billion probably if we have a very strong dictatorship, which is smart. That's, unfortunately, you never have smart dictatorships. They're always stupid. So, but if you had a smart dictatorship and a low standard of living, you can have it. But we want to have freedom and we want to have a high sentence. So we're going to have 1 billion people. And we're now at 7, so we have to get back down. I hope that this can be slow, relatively slow, and that it can be done in a way which is relatively equal, so that people share the experience and you don't have a few rich, trying to force everybody else to deal with it. So those are my hopes. I mean, these are pretty pessimistic hopes, but that's what lies ahead. Then you can say, well,
yeah, we could go on a bit, but any thoughts
really
on
good.
this?
Well, yeah, I mean, I think I generally agree. Although I don't know the time frames. I'm not saying he knows the time frames either.
Yeah, no, he says.
But when you look at, go ahead.
That's his point. It's unknowable, and I think that's of course also part of the discussion here. Where so what do we reach? Will we face 1 billion deaths or 4 billion deaths
Right.
by 2030, or because of the warming we reach in 2030? But his point is, which I agree on, that we cannot know that. We cannot know whether that will happen because there's so much uncertainty in the system, but that doesn't mean that we shouldn't assume that it will happen, because the risk of it happening is quite high, and the impact of it will be extreme.
Well, I'd also say that, and this might come as a surprise to some people listening, but we're all going to die someday. So I accept that. Now the question is,
when?
we don't know. But it's funny because I could tell you, like, you're going to die. You're going to be 97 years old, and it's on this particular day, and you become upset, even though you're probably going to live a lot longer than most people do. But the point being that we're all going to die, and so. And humans have built-in denial of that so they can go function in their lives, right? It's not like you say, let's go to a movie. No, I'm going to die someday. I don't want to go to see a movie. Yeah. So we're able to put that out of our head. And so we're certainly good at putting the 3C by 2050 out of our head. However, there are some pathways forward that are peaceful. For example, in most developed nations, the birth rate is below reproduction. And it's all because of education and healthcare and things like that lower the birth rate. And so there could be a path forward that way, where we provide education, we provide healthcare, we provide healthy lives so people don't feel they need to have lots and lots of children to survive.
It's often the discussion is, well, can women reach a point where they have as many children as they want? And I would recommend everyone also to read this report from 1972. You can find it as a PDF, Limits to Growth report. And if you just Google it for the PDF, and we can put it in the description as well. It's a very accessible book, and it also explains that if people have as many children as they want, you will see a decrease in population. And of course, I don't think that's a problem. Some people think that's a problem, and like Elon Musk, for example, he sees that as something that's very bad if there's population decline. And maybe your pension fund won't like that either. There's less, and of course it will impact societies if there's a shift in demographics. But in the end, of course, we do a decrease in population, and especially a decrease in resource use per person, and then of course that multiplied by the population could have a significant could cause an improvement in habitability on this planet.
So I think I want to talk a little bit about the Climate Week. It sort of relates to this as well.
Yeah.
And that is, I jokingly say, the first rule of Climate Week is that you don't talk about climate change. What do you mean you don't talk about that? So Climate Week, literally hundreds of events going on in New York City, and it's not centrally controlled. I mean, you could put on your own climate event at Climate Week, and you get a venue, and you either can publish it on the official list of Climate Week events, or you could keep it private and only invite certain people. But it's set up, and so there's all kinds of things. You can only go to a tiny fraction of the total events that are going on. And I went to some, and I focused on agriculture because that's an area I'm working in, and also on geoengineering. And the geoengineering event was interesting. It was put on by Suchi Toladu, who we interviewed here on Climate Chat a while ago, and her group, what is it, for the deliberate discussion of solar geoengineering. I'm not getting it exactly right. It's to try to bring together people to have a reasonable discussion on the governance issues around geoengineering and decision making. And that's what this seminar was all about. But yet it was like many others on the subject of geoengineering, where you talk about the problems of geoengineering and the risks. The difficulty in governance certainly is one of them. The moral hazard, maybe we won't reduce our emissions as much if we do geoengineering. There could be side effects, and all this is true. But what was not discussed at the meeting was 3C by 2050, 2C literally next decade. In other words, it's kind of like having a discussion about chemotherapy where you don't talk about cancer. Now, if you had a discussion on chemotherapy without bringing up the subject of cancer, it would be a very strange conversation. You could talk, you're going to lose your hair, you're going to get nauseous, it could almost kill you, just feel terrible. You got to go in every week. It would just sound like
no one would take it.
No, it's the most awful thing in the world. Of course, no one should take it unless the alternative is dying, right? That's the alternative. So I find it very interesting that in a place filled with people working on climate, and this is not a climate science week. It's a climate, think of it more as a climate solutions week. They're talking about reforestation of areas and all over, different parts of the world. How can we improve climate finance, especially to the developing countries, on and on and on. And don't get me wrong, these are all good things people are trying to accomplish. But what isn't spoken about at Climate Week in general, with at least a few exceptions I'm aware of there, is they don't talk about climate science, like where we are now and where we are headed, and how, despite all the discussions of all these, they call them point source solutions of stopping deforestation here or there, that we are not on track to keep the climate under control. And that's just the reality of it. And I do think if that was part of the discussion,
like hopeful celebration of everything that's being done without acknowledging that it's not enough, or?
Well, I think obviously there's so many different things, but I would say in general, it's of course, when I speak up and ask a question at one of the events, they don't like it because I'm asking the questions about like what we're talking about here on the show. Like, wait a second, you haven't taken into account how bad it's getting, this kind of thing. No, I think it's they're just focused. Hey, we're not talking about that. We're talking about these solutions. These are good solutions. So let's keep focused on that. And it is sort of it's natural for all people to want to have some positive story going forward. I mean, it's kind of hard to get through the day otherwise. And so I think there's some of that. But I do think that, and again, of course, there's also the whole Trump thing where they're even denying climate change. And so there was a lot of discussion of that, given the current administration and what progress can we make, that kind of stuff going on as well.
He said, she said bullshit. Yeah.
But I think would be helpful if everybody really was aware of like 3C by 2050, 2C by 2030, kind of numbers and that we're not on track and we're missing it, then there should be more alarm, which is you alarmists. You're not paying attention. If you're not alarmed, you're not paying attention. And that would help drive the narrative to the public, because the public knows even less than these people know, and would get people talking about climate change more. And the more we talk about climate change, the more there's a chance we'll do something about climate change. So right now, we're talking about these dangerous future situations without any serious plans being put in place to do something about it. Remember, this 3C is by 2050 is with the Paris Accord in place, right? Theoretically, that we're not meeting, of course, but there's supposedly the countries are scaling back their emissions and this, that, and the other thing, and yet we still have this risk of 3 degrees risk of hitting 3 degrees by 2050. I would say there's not really much of a quote risk. We're definitely going to hit 3C this century for like almost 100% sure. It might not be 2050. Again, that's leaving out geoengineering and some other things that we could step in and do. And 2C for sure next decade, or maybe a little bit more in the 2040s. And these things should be setting off alarm bells in everyone's head. And yet it's crickets, literally. And I want to say that if that story was, and by the way, there are stories every once in a while that a particular asteroid has a 1 in 10,000 chance of hitting the Earth in, let's say, 10 years or so. They do a quick calculation of the orbit and they see the error bars. There's a tiny chance it's going to hit there. That makes the headlines. Asteroid might hit Earth in 2037, and they do that. And then, of course, 2 weeks later, they have more refined orbital calculations, and they say, oh, no, there's like no chance. And then it goes away. This is like one. It's on track to hit the Earth. Like we're quite certain it's going to hit. We're not sure what year. Maybe it's going to be 2050 or 2053, but it's going to hit the Earth, and nothing. The silence is deafening, as we say. So I think there's not just a science aspect to what we're talking about today, but there's definitely a sociological aspect. We're very good at denial. And I'm not talking about the general public necessarily. I'm talking about, first of all, journalists who shouldn't be doing it, and also climate people. The climate people at Climate Week do not want to talk about dire climate science predictions. They just don't want to do it. Again, there are exceptions. Johan Rockström was at Climate Week, and he gave a talk on planetary boundaries. I got to meet him, and then I invited him on Climate Chat. We'll see if we can line up a time for him. There was that talk, but it's one of like 500 things going on over there. Anyway, that's enough of my rant about Climate Week. It's a good thing to go to if you're involved in climate. You get to meet a lot of interesting people, especially if you're working on solutions, and you can meet the right kind of people for that. I did get some guests through that we're going to have on soon, meeting them there. But I am still shocked how little people in the climate community focus on the climate science and what it means.
Yeah, I agree.
Okay. Maybe we should go to, go ahead.
I also wanted to maybe discuss these risk assessments. So why is it that these risks, that it's so hard to get the message of these risks across, the severity of these risks, but also just in a way, just to talk about these risks, right? To get it in attention for it. And this was a presentation by Simon Sharp, and I don't think it's online. I took this screenshot during his presentation. From the Met Office in 2021, and here he talked about risk assessment, the principles of risk assessment, and as we discussed also, where you have health risks, you have insurance risk, of course, you have the risk of terrorism, and flood defenses. And this statement, when we think about keeping our nation safe, we have to plan for the worst case scenarios. And of course, that's done when people talk about terrorism. They take very serious measures to defend their country against terrorism. Well, but the chance of terrorism happening is quite small if you compare to if you do the impact assessment of whatever, right? If you look at the air pollution deaths, is much higher than the terrorism deaths, so it's also about perceived threats, right? And here, as he summarized here, he said that identify the risks relates to the objectives and identify the biggest risks. To me, I think climate change is in many ways the biggest risk. And yeah, you can read it yourself. And I asked them for the presentation. I hope you can find it. But and what? Sorry.
No, I was gonna say I just made it a little bit bigger so people could read it there.
Yeah, maybe you do it like this, because then you can read the bottom as well. So what he said was that, quoting here Trevor Maynard, is it has always concerned me that our use of the word conservative has the opposite meaning in insurance to its meaning in science.
Right.
And that's
climate scientists are conservative in the opposite way that a risk manager is conservative. That's right.
Yeah, and yeah,
conservative in climate science means not telling you how bad it could get.
Yeah, and
you don't want right.
When we translate that to aerosols, for example, then if aerosols had been cooling much more, so of course the probability might be low. But if you're conservative as a scientist, you say, okay, let's focus on this, right? Let's focus on what on the most probable scenarios. But if you're conservative from a risk management perspective or a risk reduction perspective, if you want to reduce risk, you want to avoid the scenario where you have the biggest risks, you say this, we could face this, so we have to avoid this, and then at any chance we have, because if aerosol cooling is stronger, that means that there will be much more warming when we reduce air pollution.
Right.
And then we will be faced with extreme temperature increase very rapidly. So we have to avoid that at all costs, right? And I think that's where we are now, where we are starting to experience, as we talked about last week, that we are in many ways, especially regionally, experiencing extreme level of warming very rapidly, and that was, from a scientific perspective, that has often not being communicated clearly because of this conservativeness, to be afraid that they will exaggerating. Of course, that's what we've been facing the past years a lot. After the publication, even with the publication of the preprint of our research in 2022, before all these high temperatures in 2023 and 2024 happened, they were telling us that they were implying that we were lying or intentionally exaggerating, right? But of course, now it's more and more obvious that we were not exaggerating. It's like even worse than we thought it was.
Well, by the way, there's two things that happen. One, ahead of time, they say, let's just focus on the most probable thing. Hansen, Simons, they're not within the mainstream. They say all that, and then when it turns out that you were right and it's in the red zone, then they say, well, it was in the models. They look. That's when they look at the whole spread and say, let's only focus on this now. But when it turns out to be wrong, they say, well, it was in the range of our error bars, so everything is fine. So you get that too.
Honest, is it?
Yeah. Well, yeah.
Is it? I'm like, to me, that's quite dishonest. If you spend one or 2 years saying that that what we are saying is bullshit, I mean, and saying Hansen isn't part of the consensus, right? It's like that's what I've been quite surprised by. That calling.
I think they're wrong. Being dishonest would imply that they know they're doing it. I think there's a lot more psychological protection going on here, that they're able to shift their thinking without telling themselves, "Oh, I already said this before."
What do we call disingenuous? Is that what you?
No, disingenuous would mean that they are aware. I don't think they're 100% aware when they call you out. They think you're outside the mainstream, and then when they see you were right, they say, "Well, it's within the models." And yes, I mean, well, they were wrong, but I think they still believe in what they're saying. That it's I don't know. There's a lot of ways that everybody. But by the way, let's put it very clear: everyone's in denial about climate change. Even climate scientists, or maybe especially climate scientists, are in denial. I mean, that thing really blows my mind, including some of the guests we've had on this show, how they aren't particularly worried about these future scenarios.
Yeah.
And that blows my mind, because they should know, that what this means. Anyway, we've been going on. I think we should take some question, unless you have some more information you wanted to get up on the screen.
We discussed many of these things. I might wanted to discuss. We discussed it, I think, last week. We just talked a lot about the why there's so much risk of these higher temperatures. We talked about these tipping points. We could talk about it more, but I think we covered it quite broadly last week. So if anyone wants to see that, we can.
I do want to say there is one more thing I want to say, and that is, we are not saying, and you're not saying, that 3C by 2050 is a sure thing. That's not what's being said here. What is being said here is that 3C by 2050 is a reasonable possibility. And you say, well, but if you're not sure, and here's the point I want to make. I've spoken about this before, but the Space Shuttle Challenger blew up, not because there was anything, quote, wrong with the space shuttle. You might think it was. It was not designed to launch in cold temperatures. It would be like saying, I drove my car on the lake and it sunk terribly. I mean, it's a terrible, the car is made all wrong. No, it's not designed to drive on water. And a space shuttle is not designed to launch in 26 degrees Fahrenheit temperature. In fact, the rule for it, the rule was you can't launch below 40 degrees Fahrenheit. And the NASA mistakenly thought the number was 32 degrees, but it turns out you're not allowed to transport the shuttle in 32 or below. You're not allowed to put it on a truck and move it, let alone launch it, okay? But so they made that mistake, but they still launched at 26. And why am I bringing any of this up? It's because the night before the launch, they asked... 26 degrees minus... Celsius, -3 or 4 or something like that.
Minus something.
Yeah, -3 or 4 Celsius. But below freezing. How about that? So it's below freezing. And the night before the launch, they asked the rocket company, we're going around, we're getting the clearance to launch. Can we launch? And the rocket engineer said, no, you can't launch. It's predicted to be too cold. We launched at 53 degrees. That was like the coldest. And remember, this is Florida where it doesn't get that cold. It almost blew up at 53 degrees. And now you want to launch at 26. So you can't. They didn't say maybe, they said you can't. And then NASA said, can you prove that it's going to blow up? And this is very critical. Like what questions you ask and how you ask. Like, by the way, Leon, can you prove it's going to be 3C by 2050? Can you? Your answer is no.
Yes, I can, but I won't.
Oh, okay, you can? All right. Well, then, hey, we did better.
If I make us talk, but that's...
Let's do a show on that. But the answer was he couldn't prove it, of course, right? But it was totally the wrong question to ask. They should have been asking, can you prove it won't blow up? And then the answer is no. And then of course, that means you don't launch. The same thing is happening with this. Can you prove it's going to be 3? No, I can't prove it. That is totally the wrong question to ask. When you're talking about existential threats, you must ensure that they don't happen. And so you have to ask the right questions. Is this a you say, is this a possibility? Yes, it is. Is it a reasonable possibility? Yes, it is. Oh, now we have to do everything we can. We can't launch. We can't continue doing what we're doing. We have to stop. And so it blew up. Oh, then I forgot to finish the story. The NASA called back the rocket
it blew up?
company.
I didn't know.
No, the night before, they
I know.
they called back the managers of the engineer who said, you can't launch. They said, please, they had him leave the room. They had a private conversation with his bosses, who of course didn't even understand the stuff as well as he did. And they said, we expect you to say yes. And they did say yes and the rocket engineer was crazy. It went crazy. He tried all night to stop it, but he couldn't. He didn't think it would clear the launch pad. He thought it would just blow up on the launch pad when they launched, and he was wrong. He was so relieved after it left the launch pad, and it's okay. But then 73 seconds later, it blew up. And again, it wasn't a fault. I mean, the thing was not designed for it, and they pushed it way beyond its limits. And there were other problems with it, but if they launched it in warm weather, it would have been fine.
But that's the checks and balances, right? So I think that's quite an important. Like, if you have in this situation, of course, you have all these different people with other responsibilities,
mm-hmm.
and you would expect that all these checks and balances are in place to make sure that the worst thing, which is the shuttle blowing up with people on board,
mm-hmm.
doesn't happen. But that wasn't done. These checks and balances, I assume they were there in place, right? Otherwise, why they had the conversation?
Well, no, the reason they pushed it is that President Reagan was giving a speech that night, and there was a teacher on board the shuttle and for the first time, and he wanted to give a speech about how wonderful it was to have this teacher in space. And so there was a lot of pressure to launch that day and not delay it so that Reagan can give his speech, and that's what the pressure they were under.
Speech went. Right, that's of course the.
He totally changed his speech, but yeah, but of course it happened again. Then they did the study about what caused the problem and everything. They found out that it was sort of the management structure of NASA allowed this to happen, so they changed everything. And then exactly the same, but not exactly, but the very similar thing happened with another shuttle getting destroyed on reentry for again something that they could have checked on, and they just said, nah, we don't. It was optimism bias. Maybe it's not bad. We could use a telescope to see if there's a hole in the wing. We could, but let's not. And just cross our fingers and hope it's okay. So again, I want to get it back to climate.
Yeah.
Climate scientists, politicians, journalists are all, first of all, using optimism bias. Maybe it will be okay. They're not asking the right questions. They're saying, hey, Leon, can you prove it's going to be 3 years? But that's not the right question. Leon can you prove it won't be? And the answer is no. And so it's really important to keep focus and pay attention when you're listening to the climate deniers out there, but not just the climate denier, but the scientists and the journalists, when they're telling these stories, see if they're focused on the disproving the really bad thing, which you can't do, versus prove, this reversing the questions. And that's what the point I wanted to make about this is that, and I wrote, I probably should put it in the description. In 2010, I wrote an article on the Space Shuttle Challenger and climate change about this exact point, that we're not asking the right questions. That was 2010. We're still making the same mistakes now. Anyway, let's bring Stacy in.
Part of the work of accountability, I think.
She has her cat with her. Wait a second. Let's grab her while she has her cat in her arm. There we go. We wanted to.
Yes.
There we go. We got both cats.
I have both of them here.
All right. Incredible.
Okay. And I have to apologize. I hit refresh and lost all of the chats at the very beginning, which is
well,
unfortunate.
I did save some of them.
And,
If you have an important question, please.
Well, by the way, we can always go to YouTube and see them. I mean, by the way, people don't understand where we're using it.
I couldn't even scroll back there, Dan. I was stuck on both. Yeah.
Okay.
So I cannot rearrange my windows.
I do have a few pinned ones. So
there was the one thing I wanted to say is, please, if you have not liked and subscribed, would you please hit the like button? I know that there were at least 100 when I did my refresh. I saw that there were 100 more people watching than at the moment than had actually liked the show, and that helps us get up in the
algorithm.
I don't know, in the algorithm or something, so more people will be able to see this. And Martin had a number of good comments. He remarked, nothing new here, just scientists catching up with what Leon and others have been saying for years. And he was almost yelled at by a climate scientist who did not want to talk about the dangers of climate change on a Fridays for the Future demonstration. So
it is weird.
Yes, the denial is thick. And he also found Bill McKibben to be somewhat in denial in that we can install as much solar as we want. Nature does not care at all if emissions do not go down. Nothing else matters. And
to be fair, I did ask him specifically about that. Go back and look at it towards the end. I said there's a difference between solar growing and climate change, and he did accept that. And I mean, his book, to be fair, was about the promise of solar energy and the positive nature of that. But he wasn't saying that's going to avoid the climate problems. And when he did talk about that, you could tell he got a little less positive and excited, and a little. He knows about it.
I mean,
he knows about it, and he was asked about it. And go watch that part. Okay.
Yes. And then the one, it's tough to get it without reading it, but Nevitz Forever said, the number 2, C, S-E-E, or not to see, that is the question. And I thought that was very
to see
clever
or not to see,
apt.
That is the question.
Yes. Yeah. And it's, because no one's wants to look at it. Nadia was talking about Mad Max, that it was about peak oil happening, as the only catastrophe is not climate catastrophe, but peak everything plus chemical pollution catastrophe altogether. And that is something that.
Well, let's put this one up here, because this is a similar question from Michael.
That's the one I have.
Okay, I'm a bit confused. Shouldn't we focus on overall ecological overshoot and not just climate? What makes it unique? So first of all, as Leon was showing, limits of growth. There's limits to growth are built. There's a lot of things. Although the question is, which one's going to get you? And actually, if I'm not mistaken, when they updated that limits to growth 50 years later, they at first they thought there would be not enough resources. And 50 years ago, there's not enough resources, and that would be what would bring us down, right? If you run out of resources. But when they updated it and looked at the real data and they plugged it all in, they said, oh, pollution, which in this case is CO2, that's what's going to get us first. So yes, it's all going to get us, but what's going to get you first? And I think that, so I think we're going to run out, we're going to run out of atmosphere before we run out of fossil fuels. In other words, we're going to get hit by climate change. It's near term. We're talking about literally decades, not centuries. And we're talking about zero time, because it is getting us today. Now, you could argue that pollution is getting other forms like plastic pollution, PFAS. I mean, you can go on and on. There is pollution, non-climate pollution, which is harming us today. But I think the scale of the climate impacts over the next 30 years are going to be the biggest ones. Now, that doesn't mean those other things are not going to be really big problems or are big problems, but they're probably more controllable then the climate ones, once those go out of control, we're pretty much screwed, except for geoengineering. But even then, you'd have to have an organized government to do it. And so I think that it's not that climate change is the only global planetary problem we have to deal with, but it perhaps is the most urgent, is maybe the way I would put it.
Yeah.
Okay.
Another one that tags on to that or is very similar is Frosty asking, what will happen if the oceans become so acidic that any animal that requires calcium to survive cannot produce shells or bones, like the bottom of the food chain in the oceans require a shell?
I think the answer is that would be bad.
Yeah, and of course that's a
Yeah.
combination with
And-
with the coral reefs, the tropical coral reefs, being more or less doomed already at the current level of global warming, right? If the oceans will be impacted very much, and I think that's also related to Nadia, her question. Let me put it up there. What does when the shit hits the fan mean? I think there's a lot of ways to answer that, and I think that's let me share that one again. This one, I think this in a way answers the question of what the shit hitting the fan means. Is the Greenland ice sheet collapsing? Is the coral reefs dying? Is the West Antarctic ice sheet melting? Both meaning 7 meters of sea level rise, but also agriculture production declining, and of course all the increase in food prices and the impact that has on democracy and of course populists gaining strength by saying that they will help to bring the price of eggs down, while they cannot really do that, right? We have all these. We're already starting to see these impacts happening, and I think if you see now what's happening with politics around the world, with war, and of course in the Middle East, what's happening to the Palestinians, which is now officially called a genocide. What's happening still happening on the eastern border of Europe with the war of Ukraine with Russia. There's many ways where, as Meadows already calls it, that collapse is already happening in many ways. So you could always say that shit is hitting the fan too. Go back to Nadia's question.
Okay. By the way, I'm going to just throw in a little teaser here that one of the subjects we'll be talking about in the future is a new old form of geoengineering. It's talked about long ago, but never got any traction. That would work well for coral reefs. In other words, it's you can make it hyper local and just cool the oceans around the coral reefs quite inexpensively, actually, and using all natural stuff. So nothing strange going on there. And so I'll just give you one more hint. It involves bubbles. So we'll be talking about that in a few weeks. So make sure you like and subscribe so you don't miss all the exciting new stuff we're going to be talking about.
Thanks for all the followers. We now reached 5,000 followers. So it's for such a technical.
I want to have that 1 million subscriber YouTube plaque behind me when we. By the way, if we were talking about like the revised American Express Platinum credit card instead of climate change, we would 10 times or 100 times more subscribers than talking about something that and how many people does that affect, right? This literally impacts everyone on Earth and all their children, like for sure. And yet, hardly any. I mean, this has to get back. It gets back to the whole denial structure and that kind of thing. But we do have cats now.
Plus,
cats.
we need subscribers for cat.
Right. So we have cats. So it's going to increase our subscribers a lot there. Okay.
Yeah.
Let's see what else we got here. Oh, let's get Eli on. Wait. Let's get
question.
Eli on here, and then.
Okay. Right.
Eli, welcome to the show. How are you doing? And are you there? Because maybe I just surprised you by turning your mic on. Oh, okay. Well, his mic is on, but he might have been stepped away because he didn't know he was about to be called on. So, Safi, any other? Let's see. Go on.
Martin had a question at 11:08. AMOC study that put the likelihood of collapse at 70% by 2100. Does anybody know what temperatures, at what point, and what ECS they used?
Sorry?
AMOC collapse by 2100 sounds late now.
Yeah. I
is
would
it this
have
one?
to,
that one? Does anybody know what ECS and climate estimates, the recent study regarding the AMOC collapse we're using?
Oh, he must have asked that earlier, and I don't have it.
I have that one. We had a bunch of scientists on. I mean, by the way, some are just based on observations, so they're not based on future scenarios. I mean, they just looked at the statistics of how much it's weakening. I think they're using the traditional SSP scenarios. You got to think about the SSP scenarios is that the worst ones, which everyone said, thank God, we're not on the worst case emissions scenario. That we're not like increasing coal plants tremendously every month or something. And while that's true, when you look at not the emissions, but the emissions causes a forcing. Forcing is the thing that forces the temperature to change. The forcings are at the worst case. The emission scenario is not at the worst case, but the resulting forcing. And that's because, as Leon and Hansen came up with, if the ECS is really 4.5 degrees instead of 3, for any given amount of greenhouse gases, you're going to have more warming, more forcing than was assumed. And so we are seeing that. But anyway, it's almost certain they didn't use 3 degrees. Yeah, they were not using 3C by 2050. That's probably.
I think the point then is also that the aerosols were hiding more of the greenhouse gas force.
Yeah.
So then,
Well, yes, exactly. Yes, agreed with that. Yeah.
Well, I wanted to also thank NK, Jerome, Robert for their and Reese for their recommendations for people to have on. That is always appreciated. You can put it here, or you can put it in the comments on any of the shows when they're posted.
And I have to say that's better because it's very hard for me to follow the live chat, but I do go back and watch, and I'm able to read all of the comments that are stable for a longer period of time, and so it's better to put it there.
Well, I recorded them, so I'll send them to you also. I liked what Ulrich said. Economy will keep growing like a cancer. True.
Okay.
But that's most of
what
Eli,
I have
are you back?
Here.
Oh, and Joe
Eli? Okay. Don't see anything. Okay.
Yeah, I'm here. Can you hear me?
Yeah, we can hear. Mm-hmm. Yes, we can hear you.
Oh, it's in and out.
We see.
I'm sorry.
Okay, we hear you, but you might not hear us. Okay. All right. We hear a cat. Okay. All right.
Eli, your question, otherwise send it by chat.
Yeah. Okay. All right. Anyway, I think we cut. So, okay. Eli is having trouble with his connection, so that's what's going on there. Anyway, I think we covered the subject. 3C by 2050 is possible and highly probable within around that time. Maybe by 2060. It doesn't really matter if it's 2050 versus 2060. These are all catastrophic numbers. 2C by 2030s is very possible and very likely by the 2040s. That itself is terrible and catastrophic. And so far, we're not doing anything about it, and we can. So as I said, I'm very optimistic about what we can do. I'm not optimistic about what we will do. But once we start all talking about climate change, and the fact that a headline like this gets zero coverage outside of Climate Chat and a few other places, if we can change that and get the world to actually be willing to talk about these things, just like they're willing to talk about asteroids, then we can actually do something. Eli, I'm going to do one more shot. Are you? Oh, you're not on. Anyway, I can turn you on one more time.
Yeah. Okay. Can
There you are. Now we can hear you.
Okay.
So, do you have any final thoughts or questions?
Yeah. Okay. Yeah. So a few comments about the well, the models turn out to be it's within the range, but the central estimates are different. And it really has to be taken to them that you compare two models, you compare their predictions, you can look at different regions and the predictions that the models make for the different regions and different effects and so on, and you choose the model that gives the best fit with the observations, not the one that you're just holding on to, right? And they are just holding on for dear life.
Yeah. Well, they're updating them too to show more acceleration, actually, as they with the more data coming in. But yeah, and they're worried about. By the way, I mean, it does show acceleration recently, but you got to remember there was, quote, that pause in the 1990s, and that wasn't indicative of a pause. It was just a natural variation, and then it continued on its way. So they're worried that if we say there's acceleration and then it turns out there's a correction and it was just natural variation, they don't want to look bad. So there are reasons. I mean, I understand why they say what they say, but at the same time, right now, if that was true, if it was natural variation, the temperature should be much lower than it is right now, given that the La Nina conditions are kind of in place. That should send us way below the trend line, and it's not. We're still way up high, and that's consistent with global warming in the pipeline paper. So
when you don't want to look bad, I think you shouldn't give people a false sense of security when the risks are so high.
Yep.
Yeah.
Another
point quickly on the ocean, not just ocean acidification, but also heat stress is really affecting corals, and we are on track to lose 95% of corals by 2050, and that is the trophic support, the energy, the food for 95% of animal life in the ocean. So not just the ocean acidification, but everything that we're doing is threatening 95% of the animal life in the ocean. So that's also a catastrophe for people who depend on animal life in the ocean as part of their diet, which is still a lot of people. But also on the ecological topic, we've all probably heard about people going to Antarctica to see it while it's still there and looks recognizable to the way we've known it. Well, you don't have to go there anymore. You can just go to a mountain. Because what happens during warming is that ecosystems, as things get warmer, they just move up the mountain. But when they get to the top, there's nowhere else to go. So you can go to the top of some mountains and look at the animal life. And if things keep going the way that it's been going, it won't be there by 2050.
If you want to see something that will be gone, you can go many places. Yeah, that's true.
Well, here's one. Is this a denier? Here, do we actually have a denier? Imagine how spread out each CO2 molecule is. They plan to collect its amount. That's ridiculous. And like I say, it doesn't matter what the percentage of CO2 is, because oxygen and nitrogen don't trap heat, so it's irrelevant how much of there is of that.
They're talking about carbon. They're talking about carbon capture, Dan.
Oh,
it's necessary. Okay. It's necessary, but not necessarily achievable.
Okay. Well,
so that's
actually it's 20 to 30% in a coal plant flue stack, so it's actually quite easy to capture it there. But that's a whole other section. I thought they were talking about CO2 as trapping heat, but okay, let's leave that alone. All right. Anyway, so we had a good discussion, and a very, very, very alarming headline that is not being covered anywhere. And as I said, it's not just climate science; it's psychology and societal That's why on the show we actually cover a lot of people in the social sciences and psychology, communication, and these kinds of things, because climate change is not a problem of science. We know all the science we need to know. We're going to learn more, but in terms of knowing what to do, we have to act. We know that. In terms of solutions, we also have what we need to know to get started. We'll get more. Don't worry, we'll get more, but we have all we need to get started. So those two things are not the issue. The issue is we know all of this and we're choosing, as Kevin Anderson says, we're choosing to fail. We're choosing not to act, which is kind of crazy, actually. And given the risk profiles of what we know is going to happen, you would not accept these risks in any other aspect of your life. If your house had a chance of burning down like this, if the plane your kids were on had a chance of crashing like that, you would never, ever in a million years do it. And yet, for some crazy reason, collective psychological psychosis or something, we're all agreeing to sort of go la 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 la.
It's inconvenient, Dan. Change is very inconvenient.
Well, you're going to get the change. That's what we're talking about. We're talking about change. So the status quo is no longer an option, as we say, right? That's not one of the options. So which path forward would you like? The bad one or the good one? As I like to say, it's you're given a choice. Would you rather win the lottery or would you rather be waterboarded? And given that choice, we're choosing waterboarding for some strange reason. I'm not exactly sure why. But so anyway, with all of that ranting, I want to thank Leon and Stacy and Eli and everyone in the comments. And we will see you next time. Maybe, I don't want to say it yet because it's not been confirmed, but with a guest I met at the Climate Week this last week. So we'll see you next time. And thanks everyone for coming.
Thank you, Dan.
Bye-bye.
Bye.